There it is. This is really hard to do because it's a transfer function from a Bode plot, which is extremely hard for me to draw accurately on the board. And do I have my computer? Can I correct it? Probably take too long.
It's extremely hard for me to draw it on paper.
Okay.
So what's this again?
Well, you don't have to draw this. You just have to make some straight lines to it. 90 dB. This is spring 17, problem 7. You are almost certain to get a problem similar to this. In fact, I would just guarantee it. Holy moly, okay, this is going to be hard to draw.
Wow.
Look at that. Let's see if I can get some of this to work out. But this is at 200, 300, 400. This is it, omega. And this is, we'll see it where it comes out. So just to start with, what do you think you have right there at that peak down there?
Complex.
Complex what? Poles or zeros?
Zeros.
Complex zeros. So almost certainly I have some complex zeros right there. If that's true, how many let's see, what does the slope change? By how much at complex poles and zeros?
40.
40 dB per decade. So if it's already going down and it's going up over here, what's most likely the slope right here?
20.
20?
20.
20, what's this one probably then?
40.
40. So you have some idea what it looks like. If you put a ruler along here like this in a nice straight line, that may not go through 2 points that are very easy to find. But it's one of the reasons you have the little roller ruler. Can I see that, Jim? So what you want to do here is you want to put your thing here along this line. Actually, what you want to do is, since you're assuming it's 40, find some place where you can easily see 40 dB per decade and then swing it up to the line and draw that line, because these diverge more quickly earlier than you really think. Now here, and if it doesn't fit, then obviously you make some other assumption. So what are the possible slopes of that line? We think it's minus 40 dB, and that's the first one we'll try. But what are the other possibilities?
Minus 60.
Minus 60? Can it be minus 20, given that there's a slope change there?
No, because then it would have to go to 0.
So minus 60, maybe minus 80, doubtful. But so it's almost certainly the minus 40. Again, find the minus 40 there, swing it up, and make the best possible line you can. Obviously, this scale to the paper works a lot better. What is this one then? If this one turns out to be minus 40, what are we trying to do here?
Minus 20.
Minus 20. So we would find the minus 20 and bring it up to the line, and most likely it would look kind of like this. Not quite right on there. You do your best fit. Is your numbers going to come out exactly like mine? No. And you saw that before. I'm not giving you a problem as complex as the one on the homework from the Botson book with the several different complex poles and zeros and things like this. I'm not doing that. So, this one, what do we think this one is?
Plus
20 dB per decade. So again, you kind of you find 20 dB per decade where you can easily do it, roll it in, and then put a line. And obviously that can't be it. So something like this. And where are we expecting them to hit anyway?
100.
So my graph isn't very good. They should strike each other right there. So it should be like that. And because it is this way, because the complex poles like this and the complex zeros like that, that peak is dead on. Exactly the what frequency again? Omega n. So we have a couple of different things we're thinking here. We have found, oh, by the way, did anyone do this enough to figure out where these two cross?
I have about 18.
About 18? Okay.
Yeah, that's not right.
18. So, this initial negative 40 dB per decade, what does that tell you about my transfer function? Did everybody hear what Jim said? Does everyone know what that means for themselves? Initial slope of minus 40 dB per decade tells you what?
Yeah, there's two poles.
There's an S squared in the denominator. There are two poles at the origin. We don't really know if they're at the origin. They
That's what I
can
was
be at
gonna
some
say.
frequency well under.
Less than one.
Less
They're
than
the
one.
smallest.
Yeah.
Okay.
But we will assume they're at 0 because we assume we have all the pertinent data to make it. What else have we got? What is this here at 18?
S plus 18 on the numerator.
So it has to be an S plus 18 here because it has to be a 0. Good? What do we have here?
It'll
Nope.
be zeros.
Be a 0, not a pole.
Yeah, you're right. It's zeros. We don't have any more poles, do we? And then there's one other thing that's important here. There could be some constant in front of that. So, we already have some of these values. This is the one we need to figure out right here. So, what is that? We'll make it n squared.
400.
And you can leave it in that form if you want. I'm perfectly okay with 400 squared. What is it, 16,000? Something like that? What is this value right here? Zeta. How do we find zeta?
From that.
What is this distance when you read it from the graph?
That's 25.
About 20?
Yep.
I believe there's two ways to go at this point. Pardon?
Just shy of 20.
Just shy of 20, and go with the assumption about 20. You know, probably. So if we get a 20 dB raise, now notice we're using this one, but it still works out to the same. Where the two straight lines cross to the peak will still be the peaking of 20. So for 20 dB of peaking, what is zeta? 0.05. So 0.05. So what are these two together? Let's see, 0.5 times 400 would be 200. So it's 2, 20. 2. 2 times 2, so 4.
What?
Should be 40.
It'd be 40.
40?
Well, yeah,
2 times
0.25
0.05 is 0.1.
Okay, great, okay, got it. So. So it is K times S plus 18, S squared plus 40S plus 400 squared, all divided by S squared. Now we look for our flat region to figure out our K value. And I tricked you, there's no flat region.
We did start at 90 at 1.
Yeah, that was pretty clear that we started at 90 at 1. So, if we're doing this in the simplest possible way, remember we're doing Bode plot, we actually, that's before any poles and zeros, so essentially we say K times 1 plus 1 squared, not plus, times 1 squared, divided by 1 squared. What am I doing? I'm just keeping this piece, right? Because there would be two complex poles. We haven't arrived at those poles yet, so we're just assuming the simplest possible thing. So what is K?
1.
No, we need to get it.
Oh, it's the dB.
So what's the fraction, what's the factor for 90 over 20? That's where the calculator comes in handy.
4.5, but I don't know what 10 to the 4.5 is.
Fraction's 4.5.
4,
No, 31.
okay, so 10 to the 4.5.
Yeah, whatever that.
Probably your inverse log key. Inverse log
Can you
base.
explain when you got the 1 times 1 squared over 1 squared again? Wouldn't you be putting 1 omega 1 equals 1 into your body equation?
31,000.
Yep.
Where,
31,000.
why are the rest of the, what is that?
Yeah, we have
Kind of-
seven.
Oh, goodness gracious, I am on top of things today, aren't I? Did C make a simple point? Because the 1 is less than all the poles, so all the other stuff in there are still okay. So we end up with blank plus 18. That's what you're saying, right?
Yeah.
Yes.
Blank
Uh,
plus